Hello and welcome. In this video, I'm going to show you the teardown of the iRobot Roomba Max 705 combo. Opening the device is actually quite simple once you know where the screws are hidden. We'll start with the bottom cover and these 9 screws. There aren't really any tricky parts here. The plastic cover just has a few small retaining clips around the brush assembly that you may need to press in slightly. Next, at the battery, there's also a retaining clip on the connector, so be careful and press that in before disconnecting it. And don't forget the silencer here as well. After that, we move on to the bumper. There are these small tiny screws, but again, nothing complicated. The bumper itself no longer has any cables connected to the main board, which used to be common on older models. That has changed for quite a while now. Under these plastic covers, there are also 2 hidden screws. You can carefully pry the covers up. It's best to use a plastic tool rather than a knife. If you have an angled tool, you can also lift the covers from underneath. And here you can see the 2 screws. At this point, we're already finished with the top side. We turn the unit over again, remove these deeply recessed screws, and then the top cover can simply be lifted off. If anything feels stuck or doesn't come apart easily, you've most likely missed a screw, because the whole process is actually very straightforward. Now we can remove the water tank. It is secured with 4 screws and is also slightly held in place by the charging module and the infrared module on the back. That means we also need to unscrew those parts before the water tank can be removed. Disconnect the 2 tubes and the water level sensor of the tank, and you are ready to remove the water tank. The tank's water level sensor is sealed for obvious reasons, but also makes it more difficult to replace. In terms of design, the tank already differs somewhat from what we know from other PICEA designs, such as the Dyson Spot and Scrub and the Kärcher RV F7. Those are built a little differently, but the overall concept is basically the same. Next, we can remove the main board. To do this, we need to unscrew it and, of course, disconnect all the connectors as well. Be careful here, since most of them have locking mechanisms. Some of them are also ribbon cables. Now we can take a closer look at the main board itself. We have a SigmaStar SoC installed here, the SSU9383. This chip can also be found in other devices, from iRobot, 3i Robotics, or the Dyson Spot and Scrub that feature obstacle avoidance, as I've already shown in other teardowns. The main SoC is supported by an additional MCU from GigaDevice. This less powerful MCU is most likely responsible for simpler tasks, such as controlling the pumps or the lifting mechanism. We also have 8 GB of DDR4 memory from Nanya installed. On the left side of the main board, we can see the power delivery section. Next, we move on to the pumps inside the device. There are 2 of them installed here. First, there is a larger pump operating at 12 volts, which is responsible for suctioning the dirty water and transferring it into the robot's dirty water tank. Then we have a smaller pump running at 5 volts, whose job is to continuously supply water to the mop roller. Both pumps are, of course, secured with screws and connected through tubing. Whenever you take apart a device like this, I generally recommend taking a few photos beforehand so you can later see exactly where all the individual parts and hoses were originally installed. Now let's take a closer look at the roller assembly and the pumps. As mentioned earlier, we have a small 5-volt pump here made by Conjoin. This same pump can also be found in devices such as Ecovac's window cleaning robots, and in a 3.3-volt version from manufacturers like Dream. We also have the larger 12-volt pump from ET Pump, which is responsible for transporting the dirty water away. The hoses are additionally secured with spring clamps, and we also have a water flow sensor here that monitors how much water is flowing toward the mop roller. I assume this component in the cable is some kind of fuse for safety. On the mop module itself, or rather on the upper side of it, there are also 2 switches used to detect the current position of the mop module. Next, we have the lifting mechanism. 2 steel cables are tensioned here, and they are responsible for raising either the mop roller or the main brush assembly. The fact that the main brush assembly can also be lifted was never even mentioned in the marketing for the Roomba 705 combo. Why, I have no idea. Another marketing fail, simply leaving out features. Here we can also see the cleaning head module for the main brush. The same lifting mechanism is used in the Dyson Spot and Scrub, which you can see on the left side of the image. In the Dyson Spot and Scrub, there are two 12-volt pumps installed, which is why you sometimes hear that characteristic pump noise during fresh water delivery. Anyone who has watched my cleaning run videos of the Dyson Spot and Scrub will probably have noticed that already. I think the more powerful pump is needed with the Dyson for the stain removal logic, since it increases the water flow, as I have already showed in a different video. With the Karcher model, it's probably the case that only one pump is installed, although I'd have to take another closer look to confirm that. The steel cables are also secured with adhesive. Getting them out was honestly a bit fiddly, although I'm not completely sure whether I handled that in the best possible way. I think you can probably work them out with a bit of force, maybe warm the adhesive slightly, and then remove them. The lifting mechanism itself can also be dismantled, which makes it easier to remove the cables. To take a closer look at the components in the front section, you first need to remove another cover. It is secured with a total of 6 screws, along with 2 plastic retaining clips located on the left and right side, roughly at the height of the 12-volt pump and the suction motor. Once that cover is removed, you gain access to the front sensor assembly as well as other components such as the side brush motors, the front bumper sensors, and the ultrasonic sensor. I didn't remove the ultrasonic sensor here though, because it is glued in place. Let's start with the laser distance sensor. We have a DTORF laser distance sensor here. You can also find data and specifications for these sensors on the PICEA website, where many of the components are listed. So in this case, we have a sensor that actually measures the signal's time of flight, whereas many other devices that use laser distance sensors, especially older ones, typically rely on laser triangulation instead. I'll probably make a separate video on that topic in the future. Of course, we also have components like the side brush motors. There are 2 of them installed here. Since the side brushes are not extendable, these are basically just standard off-the-shelf motors. We also have an adapter for the battery. They probably ran into some space constraints and had to come up with this solution to manage the cable routing properly. And here we can also see the cliff sensors. These are not dual beam sensors like the ones used in the original iRobot designs. However, unlike those original iRobot versions, these sensors are at least sealed, so we don't have to worry about dust getting inside. Next, we have the wall sensor, which is a static DTOF laser distance sensor. This is not a structured light, or better said, light sectioning system like we see with some devices like the Ecovacs X series or Narwhal Flow. It only uses a single laser point. Then, of course, we also have some more standard components, such as this speaker here, and the optical interrupters at the front for the bumper sensors, which are triggered by a small spring-loaded lever. Naturally, we also have a suction motor here, the S25 from PICEA. I've already made a video about this suction motor as well as an airflow modification. I'll link that in the description. I'm also planning to present another modification soon, which will hopefully perform even better compared to the first modification. Next, we move on to the wheel modules. These are standard wheel modules, the same ones that are also used, for example, in the Dyson Spot and Scrub, including the identical model designation. There's nothing particularly special about them, since this robot does not feature a wheel lift function, or do they feature any special design, like it was with the VIS Nav and its dual link suspension, or the i and Hurist with their tracked treads design. Last but not least, we have the front sensor assembly. Here we have an RGB camera, an LED light, and a CMOS sensor designed to capture the reflections from the 2 line lasers. On the Roomba 705 combo, the line lasers are aligned horizontally. We see a similar setup in the Dyson Spot and Scrub, although there the line lasers are positioned vertically. Likely due in part to the green LED light used in the Dyson Spot and Scrub, the arrangement of the sensors in that module is also somewhat different compared to the iRobot Roomba 705 combo. That's it for the teardown of the iRobot Roomba 705 combo for now. If you still have any questions, feel free to leave them in the comments. And speaking of comments, I've also pinned a GoFundMe campaign there, because I'd really like to make this kind of video for the Dyson Spot and Scrub as well, especially with a closer look at the station. I've already featured the device on the channel before, also regarding the PICEA involvement, and opened it up, but I haven't fully disassembled it yet. Especially in light of the obvious PICEA situation and the denial of the biggest media outlet in the robot vacuum game to acknowledge this, I think that would be quite interesting to have a side-by-side component and design comparison. The reality, however, is that these kinds of videos are financially pretty disastrous for me. I buy all of the robots myself, and after doing teardowns like this, especially if modifications are involved, the resale value drops dramatically. In the channel's current situation, that's simply no longer sustainable because the channel itself basically doesn't generate any meaningful income to keep it running. At this point, it has become a very expensive hobby, so I am looking to find ways to make it more reasonable to do this kind of content. I'll make another update video soon to talk more about how things will continue in the future. So if you're interested in seeing more content like this, I'd really appreciate any support regarding that topic. That's it for now. Thanks for watching, and I'll see you next time. Bye.